Welcome to qnawire.
So here in this question there are three parts, and in the A part we have to calculate the work done on the aluminium and for the given condition, and it is given that the mass of aluminium is 1 kg and it is warmed at atmospheric pressure such that its temperature increases from 22 degrees Celsius to final temperature as 40 degrees Celsius. And since it is a constant pressure process, so we can use the formula for constant pressure process to calculate work. So work will be equals to minus P delta V. Now change in volume we're going to calculate by using the thermal expansion concept. So by using that concept, so delta V is equals to 3 alpha V delta T, where alpha is the coefficient of thermal expansion, V is the volume of aluminium, and delta T is the change in temperature. So first of all, we'll be calculating the volume. So we know that density is equals to mass divided by volume. From here, volume will be equals to mass divided by density, and mass of aluminium is given as 1 kg, and the density of aluminium is 2.7 into 10 to the power 3 kg per meter cube. So this is the volume, and the coefficient of thermal expansion in case of aluminium, it is 24.0 into 10 to the power minus 6 per degree Celsius. And delta V we can calculate after plugging all the values here. So we can write minus P is equals to 3 times V delta T. So P in the equation it is given as its atmospheric pressure, and atmospheric pressure is equals to 1.013 into 10 to the power 5 Newton per meter square. So P here is 1.013 into 10 to the power 5 Newton per meter square, and 3 times alpha here is 24 into 10 to the power minus 6 per degree Celsius, and volume is this thing. So we can write here multiplied by volume is 1 divided by 2.7 into 10 to the power 3 meter cube times the change in temperature is 40 degree minus 20 degree. So we'll get 18 degree Celsius. From here work will be equals to, after simplification, we'll get 0.048 joule. So this was the answer for the A part. Next, in the B part, we have to calculate the energy added by heat. So we'll be solving the B part. So Q is equals to mc delta T. It's a basic formula for heat. So mass is given as, in our case, it's 1 kg, and C is the specific heat of aluminium. So specific heat of aluminium is 900 joule per kg degree Celsius, and the change in temperature is 18 degrees Celsius. So after multiplication of these terms, we'll get the result as 16.2 kilojoule. So finally we can conclude that the heat added to the energy added to it by heat is equals to 16.2 kilojoule. So finally we'll be solving the C part now. So in the C part we have to find the change in internal energy. For that we'll be using the first law of thermodynamics. So change in internal energy is equal to Q plus W, and Q we know it's 16.2 kilojoule, plus work we know it's 0.048 joule. So it will be nearly 16.2 kilojoule only. So this is the answer for the C part. So I hope you got the problem. Thank you.